like first gave you graphing, remember we had those like 4 problems in the front of 10.1 page or practice 1. That was like I gave you the graph and you wrote the equation. Now we're just adding the translations into that too, and we're not doing tangent. So one vocab word that I probably should have given you before, but oops, oh well. So graphs of sine and cosine functions, those have a special name. Those are called sinusoidal. Sinusoidal. I guess graphs or functions. I'll say graphs. So sinusoidal graphs or functions. Those are graphs of sine and cosine functions. Okay, now here's where I'm going to color code a ton because I'm obnoxious like that. All right, so what we've seen so far. Can I hear a lot of voices? Do I have questions? Or? Okay. So what we've seen so far, we've seen y equals a times our sine of b times x, and officially it should be minus h, but I'm putting plus h because that just makes more sense. Plus h plus k. I know I'm doing a lot of colors here. I'll code it in a second. Or our other sinusoidal, we've seen y equals a times cosine of b times x plus h plus k. All right, all these colors. So what do all these colors mean? The blue one, the A. What does A give us for sine and cosine? It gives us our amplitude. Remember, that's just like the top half of the wave, like height of half of a wave or height from the midline to the top or the bottom of the wave. What is the B? Close. So now, and I did this the first time I went through the notes, I just like lost my mind and I was writing it as the period. Remember, officially, it's that your period, it does affect the period, but your period for sine and cosine is 2 pi over the absolute value of b, which I'm just going to put b. Because we're always going to be positive for these ones. So period is officially 2 pi over b, and b is that number out front, so you'll have to solve for period sometimes, or vice versa. What about the h? What is our h? Horizontal. It's our horizontal shift. And remember, it's backwards. So if it's plus a number, it's actually moving it to the left. If it's minus a number, it moves it to the right. And then how about our k? The vertical shift. And that one works as we would expect, where negative is down and positive is up. All right, so the tricky part, and I think you guys kind of saw this with the other one where I gave it to you. A sine and a cosine graph can look the same based on how much you shift them, right? That horizontal shift. So I have to be a little more specific, and the book was weirdly not specific for this first problem. But let's say that our problem should be where this is your y-intercept, which it still is. So it was not shifted side to side enough, okay? On your homework, I tell you like the point that was your original y-intercept and it's no longer. And so you have to think about how to shift it back to that y-intercept. But let's assume that this was our point. Then what we're going to do is we're going to name all of these like parts so that we can fill them into our equation. So I want my A, my B. We just talked about my H, but put it there anyways. And my K. So what you specifically start with doesn't really matter. We already said there's no horizontal shift, so my H would be 0 here. My K, how much was I shifted up or down? So think about your midline. It goes up to 5. Yeah, my midline's at 2. So like you can draw this midline. So that means I was shifted up 2, which would be just a positive 2. I think once you have that midline, it's easy to find your amplitude. There is like a mathematical way where you take the difference between the top and the bottom and divide it by 2. You can take the average like that. That works too, but we can just count it out. Once you have your midline, that's 1, 2, 3 in height. So my amplitude is 3. The period, this can be a little bit trickier. So if you think about this point right here, it would go up to a top, down to a minimum, and then back up to here. And after that point, it would repeat. You guys see how that would repeat after that point? So that's 1 period. So that runs through pi over 2. That's not my b, though. So my period would be 2 pi over b equals pi over 2. I have a cross product. So I'd have b times pi equals 4 times pi. I'd divide out my pi's, and I have that b is 4. Are we okay with that? Okay, so is this a sine or a cosine? It's a sine because my y-intercept is starting at my midline part, right? We're like halfway between my top and my bottom wave. This is a sine. Is it negative or positive? It's positive because it's like if I were just to consider this part right here, it almost looks like a linear line that's going up. So it's a positive slope. So this is going to be a positive sine. So when I fill all this in, it would be y equals 3 times sine of 4x. I don't need a parenthesis or anything because I'm not shifting it to the side. So really you don't need to put x plus 0 or anything like that. Just be 4x plus 2. For the sake of color, I should just make that up. And that's it. So it's kind of a process. But honestly, I did tell second hour after they had already gotten started, your homework today, I'm not convinced that there's a ton of work to show me. So if you don't show me work, that's fine. I mean, really the only work is like solving for your B from your period. Otherwise, you're just kind of like thinking about the graph and marking it up, but you don't even have to draw the graph. So there's not really a ton of work. Let's look at example 2, because this is asking it in a different way. So like on your test, I checked your chapter 10 test has 2 problems at the end where we give you the graphs and we actually ask you to write a sine function and a cosine function. Because you can do that. There's tons of different answers. If I'm not specific about what point I want you to take to the y-intercept, there's lots of different answers. So this example is a little more specific, but it still kind of shows you the flexibility here. Just for the record, this is your midline right here. That is your x-axis. So this midline, and I know it's not marked. I took a while to figure out. I looked at the distance between 25 and negative 45, and I saw that what these had to be. So this has to be at negative 10. So this is y equals negative 10, so we all know. Because I took this distance and I divided it by 2. So that's what it had to be down there. I did stare at it for a while this morning. I was like, is that supposed to be the midline? So what this question is saying, okay, for this point A, pretend this was your y-intercept and write an equation. Then part B is saying, okay, this is now your y-intercept. Move it over and write the equation, how it was translated. Say this was your y-intercept, how was it translated? So what we're going to notice here, and I'm going to stop color coding just to stop being crazy, but you're going to notice that your A's will all be the same. Because the amplitude doesn't change. Your B's are all going to be the same. What is going to be different is your H's. That's the part that's going to shift. So our H will be different for all of these. I'm still just going to put an H equals for all of these. And then your K will all be the same because this was just shifted down one way. Also, to help us, I'm going to name these points just so that we can see these a little better. So A happens to be at negative pi over 8, comma, negative 10. B is at positive pi over 8, comma, positive 25. Your point C is at positive 3 pi over 8, comma, negative 10. And D is at 5 pi over 8, comma, negative 45. So I just named the points to start just to kind of help us out. Okay, can anyone tell me if this is at negative 10, what is my amplitude? 35, right? If you just add 10 to that 25, because I know it's negative 10, but it's still a distance of 10, right? It's the absolute value, so 10 plus 25 is 35. So all of these amplitudes are 35. Let's do the other easy one. What is my vertical shift? Negative 10. I went down 10. So all of your K's will be minus 10. Let's figure out our periods now. So this is a little trickier, and there's a couple ways to do this. You could start from like this point, but then it cuts it off. So the easiest way to start is think about like this point to its same point, which would be through this. So this distance here, to get this distance, you can think of it as 9 pi over 8 minus pi over 8 will give you just that distance. Okay, that's how that would work. Think about like a number line, 9 minus 0 gives you a distance of 9. So if I did 9 pi minus 8, or I'm sorry, 9 pi over 8 minus pi over 8, I have 8 pi over 8 or just pi. So that means one period is pi. Again, that's not my B. I'm going to have to figure out it's 2 pi over B equals pi. And if you want to make it over 1. And again, just as a reminder, yesterday when we were working with tangent, the period is usually, or this, this period is pi over B. Go back to 2 pi over B because we're talking about our sinusoidals. So my thing would be B pi equals 2 pi. So I see that B is 2. Okay, so B is going to be 2 for all of these. 2, 2, 2, 2. All right, now the fun part. Okay, so if I'm moving A back to my y-intercept, what kind of translation is this? How did I go right or left? Okay, I have to, well, so I went left, and then how many? Pi over 8. Pi over 8. So I went left pi over 8. Left is positive, so my H would be pi over 8. So I have all my letters. Last thing to figure out, is it sine or cosine? Is it negative or positive? If this got moved back over here, is this going to be a sine or a cosine? Sine. Again, why is it a sine and not a cosine? Yeah, it's going through that midline, right? So A and C are both going to be sine because we're not located on the top or the bottom of the wave. Is it going to be a positive sign or a negative sign? Positive, because afterwards I go up. So my answer for this one would be y equals 35 sine 2. And then we do have to do parentheses here, x plus pi over 8 minus 10. Sorry, we're squeezing all that in. You will see some, like, I think your textbook actually distributes this 2 in. I hate that. I don't know why you would do that because then you can't see how it shifted. So this is how we're writing ours. You might see in some other things where they multiply it in and then they like simplify that. That's stupid. Don't do that. I don't know why your book does that. It's weird. Well, and they do it like half the time. Other times they don't do it. So it's weird. All right, let's consider B. Okay, so I have my A, B, and my K. I just need my H. So if this had been your y-intercept, how many did you move and in what direction? Pi. To the right. So now it's going to be a negative pi over 8. And what kind of function is it? Sine or cosine? Cosine. And is it positive or negative? Positive. Cosine, if it's on the positive amplitude, it's a positive cosine. So I would have y equals 35 cosine of 2 times x minus pi over 8 minus 10. Oops. Any questions about these two so far? You guys can see if I'm not specific, there's tons of answers. I think your test is not specific. I think like you get free reign to kind of name some things. What won't change is your A, your B, and your K. Those won't change. But conceivably, your H's could change, and whether you have a sine or a cosine, whether it's negative or positive, those could be different. Let's look at C. How would we have gone from this middle point here over to here? We went 3 pi over 8 to what direction? The right. So it's negative 3 pi over 8. And if I moved it, did I have a sine or a cosine? Was it positive or negative? It was negative because it goes down like that. So this would be y equals negative 35 sine 2 times x minus 3 pi over 8 minus 10. Last one, my point D here. If this had been my y-intercept, how many did I move over and in what direction? Negative 5 pi over 8. Would it have been a sine or a cosine? Cosine was it negative or positive? Negative, because it's on the bottom of the amplitude. So I have y equals negative 35 cosine of 2 times x minus 5 pi over 8 minus 10.